Shanklin, who is my predecessor as director of the comet section. Jonathan was director of the section for 25 years, which is a which is a pretty amazing achievement. And I still absolutely rely on Jonathan because I'm not a visual observer, I'm an imager. And so Jonathan is still in the section, is our coordinator of analysis. He writes a monthly column for the Astronomer magazine every month, and he really supports me as a key person on the Comet Section Committee. But what Jonathan's going to talk about today is 50 years of comet observing. I'll get your slides up and running, Jonathan. And I think, as I say, Jonathan is a visual observer, so has a very different perspective on comets to what I do. So, Jonathan, over to you. There you go.
Thank you very much. I presume it's up and down and everything works.
There's a pointer there as well that you can use. So just
right.
Left and right will go forward and backwards.
Okay, I should hopefully work with this. So this is really a sort of personal voyage, as it were. Over the 50 or so years that I've been observing comets. But I'm going to start even further back in time, going back perhaps 2,000 years. And there's the famous quotation from Shakespeare that when beggars die, there are no comets seen, the heavens themselves blaze forth the death of princes. But comets also celebrated births. And this one supposedly illustrating Halley's Comet, but possibly a different comet, was used for the birth of Jesus in the stable. So were any comets associated with my birth? Well, not directly, and if it was a fairly feeble one. And this was the closest one I could spot in the archives. Drawn by Roy Panther in 1954. This was discovered close to when I was born. And it seems that comets ran in the family to an extent. So my great-grandfather kept some diaries at the time of the First World War and drew the track of Comet Delavan below the plough in 1914. And the track that he drew in pen and ink matches pretty much where the modern orbital projections would show it to be, with the tail in the same orientation. And my great-uncle actually discovered a comet from Tasmania. Unfortunately, it wasn't named after him because he was the fourth discoverer, and so his name was never attached to it. If it had been, it might have been a bit confusing because he was also a member of the Société Astronomique Française, and in that he was down as Thomas Bernard rather than Bernard Thomas. So it's a slightly confusing name. And yes, the next step in my career was in the spring of 1970 when I'd read in the papers that there was going to be this really bright comet that you couldn't possibly miss with the naked eye in the early morning. So as a teenager, I got up early one morning to look for this bright comet, and lo and behold, I couldn't see it for the life of me. Photographers did manage to capture it really nicely, and it clearly was a bright object, but I just didn't really know my way around the sky. So that's something that societies like the Edinburgh Astronomical Society really can get over to members, where things actually are in the sky, and help them learn those star constellations and so on. So my route into further comet observing took me through school. I went to the King's School, Chester, where I studied maths, physics, chemistry, and other sciences. And also I joined the local astronomical society, the Chester Astronomical Society, where Richard Baum was something of a mentor. He arranged for a couple of visits by Patrick Moore to the Society to give lectures. And obviously, he was a great incentive to encouraging people to go out and observe. And so those studies took me to Cambridge, and what was then the new Cavendish Laboratory, but now there's a new Cavendish Laboratory, which is the physics laboratory. It was just opened earlier this year. But I still go back there on an annual basis for something called Physics at Work, where we explain to literally hundreds of school children how we actually measure ozone in Antarctica. But the other attraction of Cambridge was the University Astronomical Society, QAS, which had access to 2 big telescopes in the more distant dome in this illustration and in the closer one. So in the more distant one is the Great Northumberland Refractor, a 12-inch objective, which I still use. And indeed, I was using it a couple of months ago to try and observe a comet. On one occasion, I was successful. The next occasion, not, because trees have grown around the dome and which now obscure views lower to the horizon. The other telescope was the Thorogood, a 20-centimetre Cook refractor. It has now got a new dome, which I meant to get a picture of, because the old dome was just a bit too small for the telescope, and you had to be quite careful where you pointed it, otherwise the dust cap engaged with the wooden framework and deposited a layer of dust on the objective, which was probably not so good. And I've also discovered how to open the slit on the new dome. It transpires that you have to open it from the outside, which was something I wasn't quite aware of. And the students showed me how you went round to the front. But what they hadn't realised was how you actually open it easily. And if you go to one side and pull, it's quite a gentle pull to open it. Whereas if you stand at arm's length, it was quite difficult. But something else that QAS did was write songs. And this is one of their efforts at verse, commemorating what was a really notable comet. So I won't attempt my atrocious you want my... I won't sing this because my singing voice is hopeless, but when Kohoutek first saw his smudge of light, we thought it's just because he's been awake all night. But Kohoutek persisted, saying it would be bright. Read all about it. And I owe you a pine. This, I think, was originally Brian Marsden. It might be better than Mag -9. Floriat QAS, for we're the ones to see the feeblest comet of the century. And indeed, I did see the feeblest comet of the century with the Northumberland telescope. It wasn't actually terribly feeble at all. And this was an image that I took with a 35mm camera on the end of one of the telescopes. I don't remember exactly which one. So the telescope tracked the stars and was fixed on the comet. So really quite a nice comet. And there were a number of others around that time when I was an undergraduate. So there was one comet Bradfield, which I observed on a field trip to Arran, which was quite nice. And here it's drawn by Roy Panther. And again, I've used quite a few of the pictures that I think Martin has scanned into the archives for this talk. Another one was comet Kobayashi Berger-Milon, which was visible for quite a long time. Here drawn by John Rogers. And I think on this one, or maybe it's the next one, where Comet West was drawn by John using, I think he says 10x80 binoculars from Cambridge. I observed this on March the 1st from my college room in Cambridge, which involved a little bit of peering out of the windows and a few other things. But the 10x80 binoculars are quite interesting. I couldn't find a picture of the ones that we had, but doing a bit of Google searching, I came across this. And the binoculars are exactly the same ones that we had, we weren't issued with these protective glasses, but we perhaps should have been, because the sights, which you can just about see here, at the top here, that had dabs of paint on it, which I thought was phosphorescent paint, and which glowed in the dark, so you could work out where the binoculars were pointed. When I was doing teacher training, I borrowed a Geiger counter and discovered that it wasn't phosphorescent paint, it was luminescent paint that was powered by radioactivity. I think shortly after the finder sites disappeared. But today I use more modern 20 by 80 binoculars. Originally I had a pair of Vixen 20 by 80s, but unfortunately they seem to have relatively fragile optics, so if you drop them, the alignment goes to pot and you get double vision. But the binocular mount that I got, which was actually as a BAA award, which at one time BAA was giving awards for purchase of equipment that would help you do observing. So this I'm still using on a very regular basis for variable star and cometry work. So this is my back garden in Cambridge, and so with these parallelogram type mounts, you can just point the binoculars at virtually anywhere in the sky and get a much more stable view than if you're having to hold the big binoculars by hand. During that time, as a student, I also organised a trip to Stonehenge, where we observed a midsummer sunset, or close to midsummer sunset, through the trilithons. And Stonehenge was perhaps one of the earliest cometry observatories. Although it's banded as a solar observatory, I'm sure they would have observed comets from that site as well. One of the first periodic comets that I observed was comet d'Arrest in the summer of 1976. And I saw it on 2 subsequent returns. And here I've plotted most of the returns to date. And you can see it's got a relatively consistent light curve over each return. But for the past few returns, it's not been terribly well placed, so I haven't been able to observe it. And I think the next return, it's probably going to be too faint to be seen. So having finished my university studies, I joined the British Antarctic Survey in Cambridge, and that got me a trip down to Antarctica, where my role was looking at the ozone instrument, and that subsequently led to the discovery of the Antarctic ozone hole. But on return, there was another interesting comet, Iris-Araki-Alcock, discovered by our George Alcock, which passed very close to the Earth and was a huge object in binoculars. And then there was the forthcoming apparition of Halley's comet. The previous slide was at Halley Station in Antarctica. So for one of the things that our government does to maintain its territorial claim in Antarctica, although that claim is under abeyance with the Antarctic Treaty, is to maintain a civilian administration, which includes having a magistrate on all our stations and running a postal service. And so for the postal service, you have to have stamps. So for the return of Halley's comet, I helped design this set of stamps which illustrated various aspects of the comet and the station and Halley himself. And I arranged a trip down to Antarctica to see the comet in 1986. And as far as I can gather, I was the first person to see Halley's comet from Antarctica, because I was probably the only one who knew exactly where to look. And I was sufficiently far north that we were getting some darkness at the time when it was first seen. And then in 1990, I became the 12th director of the Comet section, following in the footsteps of Denning and Crommelin, both of whom had also discovered comets. So perhaps it was up to me to discover a comet as well. So some of the things that I originally did was I rejuvenated the Comet newsletter, the Comet's Tale, which Janice has edited for a while. Nick edited the last one, and I've made a contribution to Nick for the coming one already, and I've borrowed one or two illustrations from that for this talk. I also started the series of journal publications, the comets of the particular year. So many comets are now discovered that I've restricted to the brighter comets of the year, because otherwise it would just take up the entire journal. However, in the Astronomer magazine, I do an analysis for every single comet that our observers have looked at during the past month. That's added quite a lot to the work of editing that particular section, but it does mean that you get a bit of a description of what each comet is currently doing and whether it's doing something unusual that might require more concentrated observing. And I was also one of the first sections to create web pages, largely because I did that at work, and so was one of the first people to sort of uptake that sort of thing. So in terms of discovering comets, the SOHO satellite was launched in 1995, and today well over 5,000 comets have been discovered in SOHO images. There's now a rival to SOHO, and that's one of the coronagraphs that's on a weather satellite that is mostly looking downwards at clouds over the surface of the Earth and the Earth's atmosphere, but is also doing space weather studies, and so needs to know what is coming from the sun towards the Earth. And as part of that imaging, there's a really sensitive coronagraph that is discovering proportionately even more comets than SOHO did. And at a workshop on cometary astronomy for amateurs that was held in Paris some years ago, a number of these SOHO comet discoverers got together and had a group photograph taken. I think today there's quite a lot more that could be in such a picture, but we'll have to wait and see at the next meeting, which is due to be held in Madrid, but I'm not entirely certain that I'm going to travel to Madrid for the forthcoming eclipse next year. And then we've had some really spectacular comets. There was Comet Hyakutake, which was a great comet because it came very close to the Earth and had a tail that stretched halfway across the sky. And then Hale-Bopp, which was a great comet because it was a very large cometary nucleus. So it never came particularly close to the Earth or to the Sun, but was bright because of its size. And this is a picture of it over the Northumberland Dome in Cambridge. The same thing a few weeks later. And this is very reminiscent of the comet of the 19th century, which was also sketched over the dome. This was its original wooden dome, and that has now been replaced twice. So the previous illustration showed an earlier dome. The current one is dark copper, and I was able to photograph or image Comet Neowise over the dome. I'm hoping that I shall be able to do the same with Comet Lemon in the near future. Another event during my time as director was going to Peterborough Cathedral to see Martin Rees unveil a plaque to George Alcock commemorating his life as a comet discoverer. He was a local to Peterborough, so entirely appropriate that the plaque should be in the cathedral. Trips to Antarctica allowed me to see some comets from down there, often in very dark skies. So this particular illustration is from South Georgia, where basically there's a bit of light from the station, but everything else is totally pitch black. And then most recently, one of Rob McNaught's comets, more spectacular from the southern hemisphere, but again quite a nice comet to see in the twilight from Cambridge, and I'm hoping that Comet Lemon will be at least as good as this. I did visit Antarctica again in 2011 and 12, but I was too far south to see this particular great comet, which was rather a shame. So I was in an area where there was 24 hours of daylight, and the comet wasn't quite bright enough to be a daylight object. And then there are comets that in some senses turn out to be a damp squib, but can be quite exciting. And this was Comet Ison, which was predicted to be really spectacular, but essentially disintegrated, leaving just a Cheshire cat smile as it appeared around the other side of the sun. One of the questions that sometimes asked is, how many comets can you see in a year? And I thought, well, I'll look at my own observing career and see how many comets I have seen each year. And then I fitted a third order polynomial to it. And this is predicting I won't see any comets after 2027. And I'm not sure whether that's predicting my imminent death or whether just misuse of mathematics. But on average, if you've got a decent telescope, a visual observer can actually see about 7 comets a year. So I'm going to conclude with a few upcoming comets. Nick has mentioned a few of these, and I'm just going to look at what the potential predictions for them actually are. So for analysing comet observations, you basically take everything that is available, or a subset of everything that's available, and try and fit a mathematical equation to it. The mathematical equation takes into account of how big or active the comet itself is, which is the h0 parameter, the distance from the Earth, which is the 5 log d bit, and then how rapidly the comet is actually brightening as it approaches the sun, which is the k parameter. And most comets can be approximated to that sort of equation. Now, when you analyse all the comets that we've been seeing in this the Comets of series that I've published in the journal, a distinct pattern emerges that periodic comets tend to brighten more rapidly than the parabolic comets that just come round the sun once and are never seen again. And so that's something to bear in mind when a new comet is discovered. You first ask the question, is it periodic or is it parabolic? And choose your parameter accordingly. The MPC doesn't do that by and large. They just assign a standard value. Whereas the Central Bureau for Astronomical Telegrams does tend to be a bit more discriminatory. So Nick's mentioned Comet 2023A3, Atlas Sushinshan. That one pretty much lived up to expectations. Nick showed the bit of the light curve here where there was something of a change in behavior in the small aperture photometry, but is broadly elided over by the overall activity. What is really quite interesting is that as it's faded, it's departed really quite markedly from the mean curve. And I don't think anybody so far has come up with an explanation for why that's happening, but certainly we need to find one. So those few comets that are on their way in. First of all, the interstellar comet. There are various ways of interpreting the data. Some people decide they'll just choose the observations that report a large coma diameter. Here I've taken all the BAA and TA observations and lumped them together, which probably does a reasonable job, assuming that the observing conditions average out. And this is suggesting that if you're using a 30 centimetre telescope or are imaging, it'll reach about magnitude 11. For a visual observer using a smaller aperture, you will probably see the comet a bit brighter. And that's a well-known fact, that the smaller the aperture a visual observer uses, the brighter they see a comet. That must, I think, be a physiological response rather than something that's intrinsic to the comet, because the images, there is no aperture effect as far as I can determine. So this one might get up to 10th magnitude or so. For us in the UK, if we want to observe it, it's going to be coming out of solar conjunction towards the second half of November, when it's probably going to be 11th, 12th magnitude, but you might be able to see it visually with a large telescope in the morning sky. And I think it would really be quite exciting to see with your own eye the light from an interstellar object. So I think if it is clear early in the second half of November, I'm going to get up and use the northometer to see it. Comet Virkos, or Virskos, I'm not sure exactly how we're supposed to pronounce it, was initially thought to be possibly quite a bright object, but it is brightening as your average parabolic comet, and so it's probably going to be a binocular object later this year, but not a particularly spectacular one. Then the one that everybody's really looking forward to, Comet Lemon, that's actually brightening a little bit more quickly than the average comet. And initial predictions may well have been biased by the first point there. I don't think this sudden jump represents an outburst. I think it's probably just that the reduction didn't quite match what it should have done. But it's certainly brightening pretty smoothly, and I think a visual observer using the naked eye can probably expect to see it at perhaps magnitude 2, 2.5, something like that. So it should be very easy to see. And I'm giving a talk to the RSPB at RSPB Lakenheath site, where I should have fairly dark skies. And I'm hoping to see something like this, a comet with perhaps an 8-degree tail visible to the naked eye in the twilight sky. And 8 degrees seems to be what the program that I use for predicting tail length is indicating. Almost certainly the images will get something much longer than that, because the images definitely pick out faint things that most normal observers don't see. But a few observers have unduly or unusually sensitive eyesight, and George Alcock was one, and he could see features that are essentially confirmed by modern imaging, but which at the time people thought was his imagination. So I think human observers, all our eyes are different. No one person has eyes that are the same as another's. Indeed, my own 2 eyes are different. One sees slightly bluer, and the other sees slightly yellower. So go out and observe and see what there is. This Comet Atlas was hoped to be quite a nice object, but it's not looking so promising now, and I think it's just going to be a telescopic object. It's brightening a little bit quicker than an asteroid would, but not much. And then finally, the one that's only just been discovered, and its behavior is really quite unusual. It's brightening more slowly than a purely reflective object. And my suspicion is that at some point it must have undergone an outburst, and what we're seeing is actually the recovery from that outburst. And so as more observations accumulate, we may well see it behaving more normally. And this is one I think I'm going to have to review how we actually do the analysis. And I think this is, again, a case where the small aperture photometry is going to give us a much better picture of what's going on. But nevertheless, we should be able to see it in the evening sky, I think from round about October the 10th, if my predictive program actually works. And so all we can do is go out and again observe it, see how bright it actually is. We may not see much of a dust tail to this one, but again, if we don't go out and observe, we won't see. And if all else fails, you can make your own comet. This was one that the members of the Cambridge University Astronomical Society made many years ago. And there the snowman is peering through the Society's 5-inch Cooke refractor, which, although it's really quite a big refractor, never gets used because we have the 2 other telescopes which are bigger still. So that concludes my talk. Hopefully I've kept your time.
Thank you, Jonathan. That was great. And I love that picture at the end. I think it's just brilliant. Whilst I'm getting set up for the next talk, I can take, I think we've got time for one question. So, Alex, you had your hands up first.
Simple question, John. Do you have any comments on people using image-stabilized binoculars for observing comets?
I've never used image-stabilized binoculars. But it's undeniable that if you're holding binoculars, your hands shake. Particularly the older you get, the more your hands shake. And that really makes a dramatic difference to how faint you can see. So that's one reason why I use those parallelogram mount. It's, in some sense, equivalent to using an image-stabilized pair of binoculars, because it's holding the lenses absolutely rigid. So although image-stabilized binoculars hold your image stable electronically, it's just the same type of device. What would be very different would be photon imaging binoculars, where you've actually got an image intensifier, and that's giving you a totally different picture. So I think for using those, I probably wouldn't use that for a magnitude estimate, but it might help you to see faint features in the tail.